Welcome to the second episode of the Whiteboard series, and today we're going to talk about something pretty fun: blended execution. Execution environments are these squares right here. You will often see it written short as just EE. So we have execution environments like the EVM, and so the EVM includes languages like Solidity, but also another language, which is Vyper. And these execution environment boxes are kind of vague, but they also include things like opcodes. So whenever you think about execution environments, you might be just thinking of VMs, but actually execution environment has more. So inside this execution environment is where all the computation happens. But actually, we have other sort of reasons why you might choose the EVM over different ones. So this can be things like tooling. It can be ecosystem. It can be the docs, security testing. This can be sort of what developers are sort of using the EVM. There are a lot of reasons why you might want to use the EVM. Sort of execution environment and everything else, but there are also other VMs. So you have the SVM. People think the S stands for Solana, but it actually stands for C-level runtime. The SVM sort of has higher performance. It's parallelized. Another thing is that it's Rust-based, so it's typically more secure. Another thing is that typically we don't just have sort of execution environments. They're typically attached to a platform. And so people will have to think about, okay, do I want to deploy on sort of Ethereum and Ethereum adjacent rollups, or do I want to deploy on Solana? And applications sort of flock to these two for different reasons. One thing you'll notice about these execution environments is that they're still islands. Sort of each execution environment is its own box. And so let's say you have an EVM Solidity smart contract right here and an SVM. So one of the downsides to having, separate execution environments is doing the whole interop and bridging thing. It's not impossible. It's just sort of an inconvenience. Another way to have these applications sort of work with each other, instead of cross-chain bridging, another thing you can do is transpiling. A project that does this is called Neon. So what they do is they got the EVM, they shoved it inside some contracts on Solana, and then all of a sudden you're able to sort of just deploy EVM smart contracts. They're able to interact with SVM smart contracts, but there's still some added friction. Sort of you still have to get your EVM smart contracts, go through Neon smart contracts, and then able to interoperate and call functions from the SVM. So transpiling is sort of complicated, and that's sort of another way of having execution environments work with each other. It's not as popular, but still is a way. What blended execution has done is they got the EVM, its execution environment. They've gotten the SVM's execution environment and Wasm, which is WebAssembly. And so instead of trying to interoperate or do these complicated transpiling of contracts to contracts, what they've done is they've made a really cool blender at the bottom. What blended execution done is get the EVM and throw it inside the blender. And they got the SVM and thrown it inside the blender as well. And Wasm, inside the blender it goes. So whenever you're blending languages, that just means compiling into Wasm. There's a little bit more, but that's the main idea. And so remember how each one of these squares was its own execution environment? You can actually blend it all into a massive execution environment. So here's Fluent's execution environment. So you're able to get your smart contracts from the EVM, put them inside the blender, and deploy them on Fluent, just like this. And you're able to get your SVM smart contracts, throw them in the blender as well. And boom, you're able to deploy your SVM applications inside blended execution. One of the cool benefits of blending it all down into Wasm is you're able to have a multi-VM ecosystem. Now you're able to have EVM and SVM applications at the same time. Another thing is that it's all interoperable. So you're able to have your EVM applications call functions from your SVM and your SVM to EVM seamlessly. Technically, it's not even interop. Whenever we think of interop, we think of, here I have this execution environment, here I have this one, and I'm going to bridge over into the other one. No. Interop is interoperation between two execution environments. That's how I define it. And so now you can have the EVM and the SVM, but instead of it being interop, it's more closer to sort of just, function calls. Another thing you can have is blended apps. So here's your logic, but you can have, half of it in the EVM and, the other half in the SVM. And so I don't want to argue over which languages are better. There's tools. Languages are tools for you to interact with computers. And so whatever is best, sometimes you might need something simple. Sometimes you might need something that's more performant. Being able to have blended applications where you use the best tool for the job and you're not all day on Twitter arguing over which language is best and blah, blah, blah. Blended applications are extremely cool. And so that's blended execution. It sounds cool, but what's the catch? All these features are cool. You get sort of compatibility. You get sort of this efficiency. You have a multi-VM ecosystem. But what's the catch? Is it slow? Actually, no. Fluent also has parallelism. So, it's parallelized. Because it's one execution environment, you're able to just parallelize it. And for the EVM, I'm pretty sure you need to access lists, but that's still really cool. Another thing is that you have sort of just general performance increases. So you might be asking, but wait, why? How is it faster? Sort of typically on crypto Twitter, there's trade-offs, but there isn't really a trade-off. Okay, so typically whenever they have a ZK EVM rollup, it looks something like this. So remember, here's the EVM and here is ZK. Ouch. You have to now, and this is what all ZK EVM teams do, is they get the EVM and they try to shove it inside the tiny ZK box. They technically have to recreate all their ZK circuits and all the EVM opcodes and all that stuff in ZK. And so this is why some ZK EVMs don't support all of the opcodes. It's because it's really hard. You have to make a circuit and you have to prove sort of these certain operations. And the ZK EVM ZK circuits are for proving the EVM, not really anything else. What Fluent has done is something really cool. Fluent and their blended execution gets the EVM, they get the SVM, they put it inside the blender. They will then blend it down into Wasm. So Wasm is WebAssembly. And then they'll just prove that. So Fluent is technically a ZK Wasm execution environment. And this is the power of Wasm. It's extremely fast. It's extremely efficient. There's been billions of dollars that have been poured to just make Wasm extremely performant. It runs in every single browser. And Wasm was designed for this. It was designed for getting languages, compiling it down into Wasm, and then executing it all. And this makes Fluent extremely compatible, extremely efficient. You're able to use multiple languages, and it's high performance. It's all running ZK Wasm. And actually, EVM rollup teams like Arbitrum, which have a optimistic EVM, they originally had fraud proofs for the EVM, but they're able to have their fraud proof system with other languages using Wasm. And another one is Scroll. They have a ZK EVM, and the ZK circuits are built for the EVM, but with additional work, you can actually have it be a more generic VM. So their ZK circuits are now more compatible with more languages. I think Fluent and blended execution and Wasm are extremely cool, so I was like, let's do a whiteboard session about it. Anyways, that's blended execution. If you enjoyed this and you want to see another topic, please let me know.